Hello class, this is Mr. Hart. And in this video series, what I want to do is give you a special set of tools that will be helpful to you if you decide to continue on in science or mathematics or engineering, because they use a very particular set of tools that I want you to be able to understand that will be helpful to you and give you an advantage if you continue on in those areas. So first thing I want to look at is how you can display mathematics. Now, if you're familiar with Microsoft Word, you know that if you open up a blank document, what you can do is click on this insert button right here, and there's this insert equation bar. And that's great if you happen to be working in Microsoft Word. But the problem is these equations that you make with these toolbars up here don't necessarily translate into other programs. And so it turns out that in mathematics and science, we've used a very specific set of code that is consistent across all programs that we call LaTeX. Okay, so what I want to show you is how to design LaTeX code. So if you just open up a search bar and search LaTeX online equation editor like so, you can find a whole bunch of different sites, but I just like this codecogs.com, and what it allows you to do is to build LaTeX code. Now, LaTeX code's pretty easy to understand. You would type it like you would think about writing the mathematics. So let's just start with a simple equation that we want to display. For example, the slope of a line. Now we could type that as y equals mx plus b, right? On a keyboard, that's about the closest approximation I would get to actually writing that out. And not surprisingly, that is the format that makes the equation of a line. Now I'm going to change this to a PNG to make it a little bit higher quality. And I'm going to make the print a little bit bigger so it's easier to see. You can even make the size a lot bigger if you want. And now we have our mathematics for this image. So I can paste this image into anything that reads images, and now I have a displayed equation. But I can also take this LaTeX code into any program that understands LaTeX code, and it will display the same thing. We'll see this later on in the video series. Okay, let's do something a little bit trickier. Let's say I want to include something that has superscripts, okay? Like maybe the Pythagorean theorem. Well, to do superscript, we're going to do the caret symbol. So we can do a squared plus b squared equals c squared. And again, you'll notice that this is the displayed equation. I could click on this download button, and then I have my image that is this equation. But again, I can also copy this code into anything that understands LaTeX, and it will display the Pythagorean theorem. Okay? You can do subscripts in a similar way. So I could do maybe like from kinematics, we know that v sub final equals v sub 0 or sub naught, right? V naught plus gt. That's a familiar equation. So v final equals v naught plus gt. Okay, you may notice this looks very similar to the equations that I have in my slides throughout the class, because, surprise, this is what I use to make the slides in class, is just a LaTeX editor. Okay? I guess in regular physics we did v initial like this, say. Anyways, so we can make lots of equations like this. So we have the subscript, we have the superscript. Okay? And then, not surprisingly, you would imagine plus and minus are the same. What other things can we do? Well, the nice thing is that LaTeX has all sorts of special characters built in, designed specifically for mathematics. Now you can see this nice kind of toolbar up here, but you can always just search for a specific symbol in LaTeX, and you can find its special code. So for example, one that we used a lot was capital delta, right, which is this triangle. So if I put this backslash delta, it will automatically make the delta symbol. So then I can do something like delta x equals v initial t plus, okay, we'll show you how to do 1/2 in just a second. I'll do 0.5 times gt squared, okay? So you'll notice I don't really want this times symbol. I don't really want the asterisk symbol, so I don't need that. And how do I do 1/2? I could do 1 over 2 like this, but that doesn't quite look right. So there's another special symbol for fraction in LaTeX, okay? And it looks like this. It's backslash FRAC. And then I put the first thing I want in curly braces and the second thing I want in curly braces, and it makes that nice 1/2 right there, okay? So we can do special symbols, we can do fractions, we can do superscripts, we can do subscripts. And again, if I put this code into something that understands LaTeX, it will automatically display it, okay? Let's do some other ones, okay? What other Greek letters have we seen in this class? All the Greek letters are in there. So there's alpha, okay, beta, gamma, etc. So you can do any of the Greek letters. You can do sums, like the sum of a bunch of products, okay, or a bunch of things. And you can do a subscript to do the bottom thing, okay. And again, if it's going to be more than one character, you put it in these little curly braces. And then you can put the thing it's going to. So from n equals 1 to n equal 10 of n plus 2 or something, right? Whatever you want to sum. Okay. And we can, again, get nice displayed equations. Some of you might be familiar with integral, which you do as /int. You can do infinity. This one's always kind of a silly one to me. It's like that's what it is, yeah. INFTY. I don't know why they chose that for infinity, but that's the symbol for infinity. Okay, so there's all sorts of math things you can do in LaTeX. And again, if you're not sure what symbol it is, just Google symbol LaTeX and it will tell you the code that you put in to find the symbol that you want. Okay? And so it's a really powerful program. Another one, just another simple one, is square root. So I could do the square root of 1 plus 2x plus x squared, right? And now I have everything under that square root. So remember, curly braces means everything goes inside that thing, okay? Let me give you again one last final strong example of the power of making really complex formulations, okay? So I'm going to do a fraction, okay? In fact, let's do the formula for the universal gravitation, right? So we know that the force of gravity equals big G times some big fraction, which was m sub 1 times m sub 2, m sub 1, m sub 2 all over r squared. And there we go. That is the formula for gravity, okay? Underscores representing subscripts, carets representing squares or superscripts, slash fraction to get us this fraction bar, right? If we had some crazy formula, we could put a square root inside of that. So you have all sorts of power with this program. And if you can learn how to use these codes, it will really help you down the line when you're designing documents and theses and all sorts of things in LaTeX. So I recommend getting familiar with this, especially if you're going to do math or science, especially physics. It's just a very powerful program. And my thesis has LaTeX all over the place. So highly recommend it. Go ahead and give the challenges a try. Let me know if you have any questions, and thank you for watching.